Have you ever wondered why the sky is blue? Because the fish in the sea goes blue, blue, so the sea is blue, and the sky would bear the same color as the sea, so the sky is blue? Nope, that is not how science works. Have you also wondered why sunrise and sunset is red? The explanation for both of these comes from considering light as a wave. The sun gives out light across the whole visible light spectrum, meaning that the sun emits all colors of a rainbow, and combining all these colors will give you white light. So the sun shines white light, which is comprised of red, orange, yellow, green, blue, indigo, and violet. Light of a certain color can be thought of as a wave, which has a certain wavelength. The wavelength is the distance between crest and crest, or trough and trough of a wave. It is the distance of a whole cycle. The wavelength of red light is the longest in the visible spectrum, while the wavelength of the violet light is the shortest. The Earth's atmosphere contains dust particles and water droplets. The different wavelengths of light enter the atmosphere, and the light waves get bent. The bending effect is caused by a particle getting in the way of light, and the light wave goes around like this. The particle has to be smaller than the wavelength of the light for there to be this bending, and this is called Rayleigh scattering. The path of shorter wavelengths is bent more, and the path of longer wavelength is bent less. So red light doesn't get bent as much, while green light or blue light bends a lot to the sides. So at noon, the sun is high above our heads, and the light rays hit the earth straight, like so, and does not pass through a lot of air. But when it does pass through air though, the shorter wavelengths of light, blue and violet light, get scattered off to the sides and kind of bounce around in the air. The redder light of the spectrum does not get scattered off that much and just continues straight. So our eyes, or this snake, will pick up the blue light that is bounced around in the air, and that is why we see a blue sky at noon. But when it is at a sunrise or sunset, the light enters the atmosphere at a slanted angle, so the light ray has to go through a larger chunk of air. The short wavelength light will then be scattered off to the sides, while the red light continues straight and makes it through a huge chunk of air. So the snake here will pick up the wavelengths of light that did make it through the air, which is the red light. So this is why at sunrise and sunset, where sunlight has to pass through a lot of air, the sky looks red. We can see this effect in action with some diluted milk or soap and a white flashlight. Small particles of milk suspend in the water and scatter blue light while letting red light go straight through. The milk water here is like a patch of Earth's atmosphere, in which tiny dust particles scatter blue light off to the side so a person can see. So I am shining the flashlight from left to right, and we can see that our patch of sky has a tinge of blue, so the milk looks blue. This is because the shorter wavelengths of light are scattered off to the sides, while the red light passes straight through to the right. So the blue light that we see comes from the short wavelength light scattered off to the sides by the milk. Now I am shining the flashlight from far to near, so straight at you. The red light in the white flashlight would not get scattered very much. It pretty much continues in a straight line through the milk, and it goes into your eyes in a straight line. The blue light will be scattered off quite early on to the left and right and will not be able to reach your eyes. So the red light makes it through the milk because of its long wavelength, and we see red. So we have kind of created a patch of sky and a sunrise and a sunset in my own room, which is pretty cool. Technically, violet light scatters the most, but our eyes are not very sensitive to violet light, so we mainly see blue. You know that we're meant to be dead by now, right? The shorter the wavelength of light, the higher the energy of the light wave. The shortest wavelengths are X-rays and gamma rays, which can kill our cells. And there is a lot of X-rays and gamma rays in space, but why haven't they reached us? The shortest wavelengths of light, X-rays and gamma rays, are scattered off very quickly when they enter the atmosphere, so none of the high energy light makes it through very far. So if there were no atmosphere X-rays and gamma rays will get to our body to cause DNA mutations, tumours and cancer. But why is the ocean blue then? The short answer is that H2O molecules absorb red light and violet light in the electromagnetic spectrum, which means that light that reflects off the sea and goes into our eyes is blue. But why that is much more complicated. Thank you so much for watching this video. If you found this video cool, please hit like and subscribe and ring that bell if you want to see the next videos I make. Tell me what I should do next by leaving a comment down below. Thank you and have a good day.